Hello, this is Alan May. I will be the moderator for this 1 hour session. So welcome to this OWASP 2022 virtual AppSecEU session. The presenter is Michael Boeynaems. I will ask him to introduce himself. I will say a few things after, and then we'll start. Go ahead, Michael.
Thanks, Alan. So hi everyone. In fact, I moved my slide to introduce myself to the end, just to do something different. But I really want to cover the content today. So let's see if we get to my bio slide. It's not the most important thing that I want to talk to you about. But so today is about layered threat modeling. Layered threat modeling in the sense that we distinguish multiple layers in the threat modeling as we all know it. And that's really what I would like to talk to you about and see also what your opinions are or perhaps questions that you may have. So this is presented by myself. There is a co-creator, Matthijs Hubrechtsen, who really helped me a lot in creating these slides, who also works together with me in Splinter. So just as a short agenda, we have a small hour, and I really have some things that I would like to talk about. But it's about layered threat modeling. And I first want to introduce the difference also with solution threat modeling. And I also want to cover some of the literature review, the methodologies, frameworks that actually support this layering. And so it's not something that we invented ourselves. This talk is basically a summary of things that we have read and that we think are useful in practice. Now, to make it a bit more concrete for this talk, I actually use the cloud as a problem statement, as an example, because it's always difficult in these talks to use real live examples from customers. It's not really allowed typically, and so I created this cloud service model example, which in the end, actually, I must say, even though I say it myself, which I will definitely be using in the future, because I think it's pretty useful and a pretty nice model if you ever need to assess the difference between cloud service models like IaaS, PaaS, CaaS, and so on. So we will cover that as well. And then I want to deep dive in the method, which is, if you know solution threat modeling, and I call solution threat modeling the traditional threat modeling type of way. If you know that this method is not new, so we model the context, we identify threats, and we manage controls. And I have a short practical demo as well using Archmate. Let me just take the laser pointer as well. So a very short practical demo and some conclusions and common pitfalls that I also would like to present to you. So as an introduction, threat modeling, I hope you all know it. I hope you all know about solution threat modeling. And typically a solution threat model, in my experience, is focused on a single solution. And here on the right of the slide, I just have an example, which we will not cover any more in detail in this talk. But we have DFDs, or I've used the DFD here to actually model a solution with the threats, with some controls, with the assets that may be relevant. And typically we use different notations. So DFDs are ones of the most known in this context, but we can use UML diagrams as well. We can use Visio documents even. It doesn't really matter. We also can use various techniques like Stride, Linden. There are many more. Perhaps you use them. That's not what I will be talking about today, but you will see that there are a lot of similarities with architectural threat modeling as I presented here. But most importantly, and that's I hope something that you can take away, there are also important differences. So if we look at the software development lifecycle, a typical software development lifecycle is displayed here, and perhaps you use some kind of agile model, but I put a nice repetition arrow here, which basically covers everything, right? So it's easy. But we typically do solution threat modeling in the design phase. So we gather the requirements, then we have the design, and then we should be doing threat modeling. And again, this is not something that all companies do already. So solution threat modeling is a must, and you should be doing it during the design phase. Then we go to build, test, move to production, etc. This, I assume, you know. And if I may make an analogy with the farming business, I'm not sure if it's a good one, but okay, analogies are always nice. Then typically, if you use solution threat modeling, it will help you in designing a barn securely. It will help you in designing a solution, one single solution, securely. Now, typically as enterprise security architects, and I actually asked some of you answered the poll before this talk, whether in your company you make the difference between architectural threat modeling and solution threat modeling. And I see that many of you actually make that difference. So that's nice to see. And so I guess you understand when I talk about perhaps you do not want to build a single barn, a single solution, but instead you would like to architect an entire farm, right? Like you see here with a windmill, with chickens and people and buildings and a nice fence. And as an enterprise architect, and I'm not yet talking about security architecture, but as an enterprise architect, you attempt to make a model, you try to architect this entire farm. And as an enterprise security architect, you will try to use business attributes, that attributes are important to the business, and you would like them to traceably link to some of the deep down security controls that you have in your solutions. So this is basically my starting point. How can we do threat modeling at this level, at the level of the farm, instead of at the level of the barn? And so as a software architect, and there are different names. In some companies, it's called solution architecture, solution security architecture, software security architect. These people typically help to design a single barn, a single solution. And that's ideal to actually use solution threat modeling. So when I talk about, again, solution threat modeling, it's the threat modeling that we all know with the DFDs and all the like. Using this kind of threat modeling, a solution security architect is able to define system security controls, development security controls, which are very important. So they are extremely important. And it's at the level of the solution. On the right of this slide, you see enterprise security architecture. It's not better, it's not worse. It's just a different role with different goals and different responsibilities. And this kind of person helps design a complete farm. And our argument is that actually this kind of person can employ architectural threat modeling, what we're going to present in this slideshow, to actually reach that objective. And that's one of the very important differences, in my view, between the solution threat modeling and the architectural threat modeling. The actual goals of architectural threat modeling are much different. And we want to define security objectives, security principles, and more generic security controls. So we are at a higher level of abstraction compared to the solution architecture. So again, on the left, you see here the SDLC, where we do solution threat modeling. That's designing a single barn. But the argument of this presentation, of this talk, is we also need to threat model at the enterprise architecture layer. And we all do it. It's the same with solution threat modeling. Everybody does it. Perhaps we just do not do it formally, or we do not have a formal method that we follow. But everyone threat models, also enterprise security architects threat model. In this talk, I would like to present a more methodic, more strict approach to that kind of threat model. This is a bit of a theoretical slide to see, okay, what we are discussing here. Does it actually, or is it backed up by literature? Is it backed up by frameworks like TOGAF, SAPSA, Zachman? And to be honest, I'm not sure that I was allowed to show the SAPSA matrix. You can just find it on the internet. But I did make the attempt to check the licensing of SAPSA. And it was a bit unclear. I also did not ask them because I guess I would have been allowed to use it. But in talks and trainings, it's not allowed just like that. So that's why I blurred it. But you can also DuckDuckGo it if you would like to. And in fact, SAPSA is much, or the SAPSA matrix is very similar to the Zachman matrix. But on the left, we have TOGAF, where we have an architecture continuum and a solutions continuum. This is not a talk about TOGAF. If you don't know it, it's not that much of a problem. But what we see is that actually all of these frameworks, TOGAF, SAPSA, Zachman, they make a difference between the higher layer architectures and the more solution-focused architecture. If we have talked about solution threat modeling in the past, again, we see that the threat modeling is more at this solution architecture layer and not at the enterprise architecture layer. You also see the goals, again, they are different. At an enterprise architecture layer, we would like to come up with threats, with risks, with generic principles that can be used. In SAPSA, we call it the contextual, conceptual, and also logical layer, whereas the solution architecture is more the physical and the component layers. So all of this just to say that, okay, we have investigated this as well, and we've seen that actually all of these frameworks support this kind of distinction in layers for threat modeling. If we now go to a more concrete example that we can use throughout this talk, again, I have focused on cloud service models because I think it's a question that all of us face at some point in time and that all of us can also relate to. If we have to choose between a cloud service model as a company, do we have to choose IaaS? Do we have to choose PaaS? Can we use all of them interchangeably? We have to have a reasoning to actually explain to the business why or why not we can use a certain service model and which principles we then must be following. And for me, this is a perfect example of where architectural threat modeling can come into play. So I do not pretend to be a cloud expert. I also do not pretend that I know more about what the cloud is than all of you. But this is just the essential characteristics, the service models and the deployment models, the NIST definitions of a cloud, basically. But what's more important is here on the right, I copied a matrix from Microsoft, which is often known as a shared responsibility model. So depending on which service model you choose, you see SaaS, PaaS, IaaS here, depending on which service model you use, you have different responsibilities, or better said, the responsibilities may shift to the cloud provider. This makes a lot of sense. So, for example, if you move to the cloud, whether it's IaaS, PaaS, or SaaS, the first thing that is out of your control is the data center. So that's also the first thing that is actually the responsibility of your provider. And that's what we mean with the shared responsibility model. Information and data almost always remains your responsibility. As a cloud customer, that remains your responsibility. But often the infrastructure, the data center, the physical network, etc., that shifts, the management of that shifts to the cloud provider. All of this just to set the scene at what I would like to do or to show as an example of architectural threat modeling. So okay, and now we can dive into it a bit. If you want to do architectural threat modeling, there are several steps that you need to take, and that's very important. And they are pretty similar again to the default traditional threat model steps that you need to take. Step 0 for me is very important. It's actually to define a meta model, to come to a common terminology that you can use throughout the enterprise, perhaps even across enterprises. That's what we see more and more often, also thanks to conferences like this, that even we want to share information, to share threat models across organizations. Well, to me, that requires a shared meta model, a common meta model. And again, there are actually some initiatives listed here that define these common meta models, of which one of the most important ones is the ISSRM paper. So you can also find the references on the slide, where they define really, okay, what is important and what do we need in an information system security context. And we need the business asset, we need risks, we have impacts, we have threats, we have vulnerabilities. All of these are terms that you're probably familiar with, but that need to be very strictly defined if we start using a certain framework, a certain method in a company. There are also some other references. NIST, Adam Shostak, of course, one of the biggest in this game, the Open Group as well, that have defined some concepts that are useful for threat modeling. And again, you see actually similar concepts appear, like risks, events, impact, threat events, in this case, threat agents. So they make sense, and we can link them to the ISSRM model as well. And then we have TOGAF and Archimate. And Archimate, well, we'll be using Archimate here because I think it's basically the standard these days, the de facto modeling standard for enterprise architecture. And so we need to map the meta model, the ISSRM meta model, to Archimate as well. And these are some Archimate elements. We will come back to that. It doesn't really, it's not that important for this talk, but we had to make the mapping between ISSRM concept and an Archimate element. And that's basically what you see here on the right of this table. These are the elements that we use in this talk and how they map again to the ISSRM concept. So for example, for a threat, we use an event and an actor. For a threat event and a threat actor. This may seem easy to do, and it's not that difficult, but you must have this meta model before you can proceed. And so what you see here is actually the meta model that we use. It's a bit simplified. I got rid of the invisible relations, the implicit relations. But basically, this is a meta model that we have used and that proved very useful. And it also incorporates all of the elements of ISSRM, all of the concepts of ISSRM, but then mapped to the Archimate language. And this meta model is the one that we use. So what does it say? Okay, we have threat events. We focus here on threats. Threat agents, and they can initiate threat events. A threat event typically exploits a vulnerability, etc. And that's why we need security requirements to actually control these vulnerabilities, and therefore to control these events that threaten my or the organization's assets. So we talk most about the left part, but you will see in the demo that actually I leave the door open to also move towards an impact assessment, which is typically different from threat assessments. Threat assessments, they typically are about likelihoods, whereas impact assessments, well, they are about impact, and you need both to come to a risk. Threat modeling usually focuses on identifying threats, identifying the likelihood of these threats. Then we have step one, and I will show that also a bit in Archimate, but these are the screenshots because Archimate can be a bit overwhelming in that case. The model became a bit bigger than initially expected. That's just an example for this talk. But as I mentioned, I really liked it, so I'm going to keep using it in the future. But here you see how we modeled a potential cloud architecture in Archimate. So you see we have a business process. So we can have business processes that are supported by applications running in the cloud, and that would then be a SaaS service model. We can also just hire a fast runtime. We can use Azure Functions, for example, and run an application in this Azure function. Then we are more in the fast service model. We can just rent a Kubernetes cluster. Then we're more in the CaaS service model. We can have I don't know, a PHP platform. Not sure if that's the best example, but then you're in PaaS. or you can just hire or rent out machines, and then you're in an IaaS kind of service model. And so for me, this is very useful because it shows exactly how this is built, not linked to technologies, not linked to Azure, to AWS, to Google Cloud. It's just conceptually what makes up a cloud architecture. And so why did we use Archimate? Again, because this is not so easy to do in other notations. We make the link here between infrastructure architecture to application architecture to business process architecture. It's not easy to have this link in other notations, and it is the de facto standard, as I mentioned, in many of the companies that I was able to work with. This is the standard to actually model this kind of problems. I also have a nice statement, by the way, of Nick Malik at the time when he was working for Microsoft, where, and there's a lot of truth in this statement, and that's also what, because sometimes people ask me, well, what's the difference between UML, for example, and Archimate? Why do we need to use Archimate? I think it's, and there I agree with what Nick Malik mentions, it's just a difference in what we want to describe. In Archimate, we can describe the farm, an entire organization, whereas you need UML for the more detailed design, the single solutions that you want to design, like sequence diagrams, state diagrams, all of these things. They are very important if you focus on one single solution, and both are indeed needed. So it's not that the one replaces the other, not at all. So step one is done. We have a model, we have an architectural model in Archimate. And here you see again these different service models. So you see that I was a bit caught up in this because again, I think it's useful for the future as well. It's just a shared responsibility model, but then modeled in Archimate conceptually, not by Microsoft, not by any other vendor, but just a conceptual model that we could use in this threat model exercise. So, okay, then we are at step 2, and now we can identify threats. We just follow the methodology, and we always start with threat actors, but threat actors, it's not the core of this talk. I want to focus on threat events in this talk. But anyway, we need to, or we cannot ignore threat actors. So here I gave some examples of potential threat actors. And I really like the open security architecture OSA threat classification method. It's to classify threats, not just threat actors. But thanks to actually this method, we can also apply it to the threat actors. So for example, we have internal threat actors, we have external threat actors. Some of them can be can really be deliberately attempting to attack our organization. Some of them can actually just, well, they can make an accident, which also has impact to our organization. And we can also have some more force majeure kind of threats, like an earthquake, perhaps, or something like that. So these are threat actors. Very important to think about this. Is the NSA your threat actor? Is it a hobby attacker? Is it an internal employee? That's all very important. It can even lead to some red teaming scenarios, etc., based on who are you afraid of, or who do you think may be attacking you. But now we move to actually the core slide of what I want to show. And again, I will also attempt to show it a bit in a demo kind of way. But here you already see it, and there's a lot of on this slide. But what is shown here is actually the end result of a threat model session. So what you see here, and I'm circling it, I hope you see my laser pointer. What you see here is our cloud architecture, the infrastructure layer, the application layer, the business process layer. We have here the service models. That's what we discussed a couple of slides ago. And on the right, we have the threats, which are the result of a threat session. So I could have a threat session with Matthias, and we come up with all of these threats, and we link them to a certain component, a certain element in this architecture. So that we actually know which threats apply depending on which service model that you use. You see also that there are some common threats, by the way, here in the system threat profile that apply to any kind of system. But okay, let's ignore these for now. How did we come to these threats? Because again, there is not much difference. Could we have used Stride? Perhaps we could, but the thing that I don't like about Stride is that it's too open, and some people actually like it because it's open and because you have to spark creativity and you have to indeed be able to have a brainstorming session. But in reality, if I really have to do it consistently across different enterprise architectural projects, I think it's good to have some kind of threat catalog, a reference that we use. A very good resource for architectural threat modeling that we found is the CAPEC mechanisms of attack, and I will show you that also during the short demo. CAPEC, it's a MITRE resource, so we all know MITRE from the MITRE attack framework, I guess. But they also have a CAPEC, a common attack pattern enumeration and classification, where they actually categorize all the threats that they also have in the attack framework in some kind of patterns, meta patterns that we can very well use in an architectural threat model session. I'll show you that list later. We can optionally cross-reference it with the KW catalog, and if we have time, I could show you that. That's just a paper where somebody actually made the effort already to go through CAPEC, through all of the attack patterns of CAPEC, and filter out the ones that are more enterprise architecture related. So, and let's say that CAPEC mentions a CSRF attack, which is actually an attack. So attack threats, some people would like also to have a discussion, maybe a discussion we have at the end of this session. But a CSRF attack to me should not be a threat that we model in an architectural threat model session. We should more talk about higher level meta patterns. And that's what we're going to do. But the KW paper actually already does that for you. So they have made a filtered list of CAPEC, which they think is important at an architectural level. And of course, as we always do with threat modeling, we have to analyze the threat in the context of this model. What you perhaps also see here, but again, I will show it also in Archie, and then we can dive a bit deeper into it, is that we linked multiple threats to threat profiles, just to make it a bit more, well, to make the overview a bit more clear, so that we don't have to link all of these threats to single elements in the cloud architectural model. So again, this for me is a core deliverable of enterprise architecture. Why? Because now you can say, okay, we have, and we'll come to the controls in a minute. But now you can say, okay, if I am doing PaaS, well, then these are the threats. So all the ones below PaaS, all of these threats should be solved by my cloud provider. Are they solved? You should check it, and either it's contractually agreed. I know it's difficult with the big players like Azure and Amazon. You're not always in the position to negotiate. But anyway, you should be aware of these threats, and you should at least document that it is assumed or that it is known that these threats are in fact mitigated by your cloud provider. All of the ones on top of it, so if you go for PaaS, all of these threats that are above the PaaS line should be solved by you, should be controlled by you. And so this is ideal to come up with some controls, some cloud security controls. And we have cloud controls matrices, of course. We have an ISA top 10. They should be aligned with each other. And these are the threats that we need to protect against from an enterprise architectural level. Step 3 then is to actually control them, to identify controls. And this is a step that was not completed here in this presentation, because I want to focus on the threat identification, and that's what threat modeling is about, identify the threats. Of course, in the end, you should end up with a set of controls that you have to apply, But that was not the main goal of this talk. So what you see here is that the purple things are actually the control profiles. So for each threat profile, we have a control profile. But you see that I only identified 2 concrete controls. And just in this example, where we have controls that are actually attempting to mitigate some of these threats bundled together in a control profile. This is what I mentioned. So depending on the service model that we choose or that you choose, either you or the service provider will be responsible to actually make sure these controls are in place. And the threat actors are also not seen here. Why? Because, well, in this is actually a comparison exercise. So we compare PaaS with IaaS and CaaS, etc. So the threat actors can shift. If you go for on-prem, you do not need to worry about a cloud administrator, for example. So that's why they shift in this example. Now, okay, enough of the talk. Let's just show some examples because I think it's very useful. And I want to start from the CAPEC mechanisms, just to show you that, and perhaps some of you already know it. But so I have the CAPEC mechanisms of attack. So it's just a resource of MITRE, as I mentioned. And what's very important or very useful is that they actually have categories. So the C is a category. It's not really an attack category. It's more categorized based on intent. But okay, it's very useful to have this. But what's even more useful is these meta attack patterns. This is what we need at an architectural level. So for example, bypassing physical security is a meta attack pattern. I'm not sure if you can read it. It's pretty small, but I will quote: meta level attack patterns are particularly useful for architectural threat modeling exercises. That's what we need it for, and that's what we use it for indeed in this talk. If you even click further, you go to the standard attack pattern, and these for me are too detailed. So that's useful in a solution threat model session, perhaps, but it's too detailed in a architectural threat modeling session. So I really like these mechanisms of attack and especially these meta attack patterns. For me, they make up the threat catalog, the standard threat catalog for many organizations out there. And so you can build your own threat catalog, but I think MITRE is very known, and perhaps the site is not doesn't look like the most modern one, but the content is great of this list. Now, what we usually do, and that's something that I should add, is actually you see an Excel here. I will zoom in just a tiny bit. In column F, you see these meta attack patterns. But what we usually do is, okay, we still translate them here in column D to a more, to a threat in our own wording, because it may be easier to manage definitions yourself and to make sure they align with definitions of the company that you work in. Rather than actually reusing directly the meta attack pattern definitions, because there may sometimes be differences in opinion or differences in concepts that CAPEC is using in contrast to what you're using in your organization. So usually we translate them still to a threat, and sometimes even we split them. So flooding in the context of cloud, it's not just DDoS, but it's also that your resources can be exhausted, that you perhaps chose a machine that is too lightweight, can also be a threat to availability. And so that's just a simple translation. You don't need to do it. You can use the meta attack patterns directly, but that's what we like to do. Here, by the way, I will come back because you see that there is no meta attack pattern linked. And this Excel, so I'm going to switch to the Archie tool now. These patterns, and I hope it's large enough, but I will also just explain what's on the screen. All of the threads that you saw in the Excel are also returning here. So I just imported them from the Excel into my architectural threat model. In your organization, if you have a common repository of architectural artifacts, these threads could be part of your common repository. And it's these threat events that we can actually easily link to some kind of elements. So let me just show you a very quick demo, because the cloud example was perhaps a bit too big for some of you to see. For example, imagine that we need a logging component, and I'm not going to talk about tooling, so we're at the enterprise architectural level. Let's say that we need to introduce a logging component. It's an application component, and we want to threat model it. So we organize a session with architects, and we use the CAPEC threat catalog, and we actually say, okay, I guess that for this logging system, well, traffic can be intercepted, perhaps. And so that's a potential threat to the logging component. I link it. I usually use the association relationships. We can have a discussion on it. But anyway, it's a potential threat. Or an easy one, loss of compromise or loss or compromise of logs. Okay, I also link it to this component. And then, of course, we have to follow our meta model, by the way. So this actually is following our meta model, and I have a small script as well that actually sets some properties on these relations. Why? Because again, I think we need to move to a more strict methodology, a more stricter approach to this architectural threat modeling. And you see that I now added properties of likelihood and impact of this threat. So for example, the interception of traffic, it's a likely threat with a medium impact. I don't know, it's just an example. And we can even add some context, traffic logs going to the logging component can easily or can be intercepted. This may have a medium impact because of the content of the logs. Just a quick example. And so that's how we document our entire threat model in this architectural model. And of course, the next step is then to start defining controls. So that was step 3. Let's identify controls. By the way, I skipped the threat actor phase. But in this case, let's say we have an internal malicious employee who is possibly initiating these threat events. And then we can have some requirements. We can protect logging data in transit. And according to the meta model, that's an implicit relation. I can also link it directly to this connection, not to the threat, because depending on the context, the control can be different. And so it's not that the control solves the entire threat. You typically need a contextualized control to actually solve this threat or mitigate this threat. And this is an easy threat model. So it's similar to the one of the cloud. We can even have some other controls for this compromise of logs. I don't know, require authentication. Okay, this is not really the greatest threat model of my life, but you see the point where we actually add controls in step 3 to this threat model. And that's just the approach that I would like to get more accustomed to have this more strict method. And what's great is that typically we also need to generate a traceability matrix. Well, we can use scripting in Archie to actually auto-generate this threat traceability matrix. Sorry, I will show it again. So I just ran the script and then it copies all of this information to the clipboard. And you see here that we have the logging component with 2 threads. And also we have for each thread a control that was identified. We could even use this to assess risk, because now we have the likelihood that's typically related to the threat, but we can also have the impact. That's what I added on these connections. Because the logging component, it may have a medium impact. So we could actually use this as well to move to risks. And then we have the full meta model. Let's see if I still have it here. Then we can actually start building this meta model concretely in this example of the logging component. Okay, so just as a final example, I will show this threat model of the cloud again. So it's exactly the same, and we have these elements, and I linked threads to the elements through a control profile, or sorry, a thread profile. Doesn't really matter, and we could also have linked them directly, which is exactly what we also did here in this logging component example. So I hope it's a bit clear, but this is actually what we present. And of course, this is architectural threat modeling as we see it. Let me switch back to the slides. So, okay, we've done a lot. So start from the CAPEC mechanisms. I've shown you that, so not going to repeat it. I told you that the meta patterns is actually what we need in an architectural threat modeling session. But the standard patterns, they can be still very useful in a more detailed solution threat model. Here I also used Archie to actually do this in practice. So it doesn't have to be Archie, but that's an open source tool, again, used in many enterprises, but it can also be Sparks or whatever. And I auto-generated this traceability matrix from the model, which is great for documentation and which immediately can show you, okay, we have no controls for all of these threads. But that's a problem, because if I take, for example, IaaS, I'm actually responsible for all of these controls. And so we have to define these generic controls, perhaps even principles and objectives, to make sure that we make the correct choice and that we treat these cloud service models securely. So, okay, a lot of talking. It's always a bit strange to not see your audience or to not get immediate feedback. But let me jump to the conclusions and some of the potential pitfalls that you can also face. Ellen, I think I still have some time to further go over these conclusions.
Correct, for the Q&A. So far, no questions. So
okay.
The audience can not be afraid to prepare questions. We'll have enough time. Back to you, Michael.
Thanks. So yeah, indeed, ask questions. It's great, I think, to have this kind of interactive sessions. But so the main conclusions. So in this talk, I focused on the layering. So most on the architectural layer, actually, where we said, okay, this is also supported by TOGAF, by SAPSA, by Zachman, and all the like, where we now focus on the contextual, conceptual, and logical layers, whereas typical solution threat modeling is more focusing on the bottom layers. But a question that I get often, and that I also often think about, is what exactly is the difference with solution threat modeling and with the threat modeling as we know it? And I think the main differences are in the scopes and the goals of what we want to do with architectural threat modeling. And because the scope and these goals are different, we must move to other techniques. We must move to other notations to be able to link it to what enterprise architects do in their day-to-day jobs. So to summarize, the methodology is, I think, similar. I would love to have it a bit stricter, and that's also what is presented here. It's not a free-for-all anymore, it's more strict. And I think it's also different techniques that we use. Archimate, TOGAF, again, actually you could do this also with other notations, but again, I think we should attempt to standardize as much as possible. OSA and the CAPEC library of MITRE are very thankful resources that you can use in practice. And for the controls, again, that was not the focus of this talk, but I think since we have here, I showed you how we can automate this generation of threads, of traceability matrices. Perhaps we can even automate the generation of controls in the future. Looking at OSCAL, I'm not sure if any of you have worked with it, but it's also a way to actually represent controls in a more computer readable language, you could say. So it may be possible to actually start integrating with that automatically as well. Perhaps a talk for in a couple of years. Again, for me, the main differences is the scope. So we focus here on enterprise architecture deliverables. We're not focusing on detailed design. What do I mean with enterprise architecture deliverables? It's reference architectures. It's architectural patterns that we actually want to assess, that we want to threat model before we validate them for use, for generic use in an enterprise. The goals are also different. The goals from architectural threat modeling, to me, they are defining security principles, objectives directly linked to the business attributes where it all starts. We also need some traceability, as sometimes people may ask you, hey, but why do we have this detailed security requirement, for example, of having to be re-authenticated after 30 minutes? Well, you should be able to use the architectural threat models to actually jump from the deep down security requirement to the objective principles, the goals that we want to achieve. And so I hope that with this talk, I showed you how we can facilitate threat modeling for enterprise security architects. That was the main goal. That's how we also use it. And I think it's very useful like that. Last slide, Alan, and then let's see if there are some questions in the meantime, but some common pitfalls to avoid. So we have run into some of these ourselves. So to save you from them, I think it's important to try to avoid these. And an example is the overlapping threads. Depending on the catalogs that you use, you can have many overlapping threads. Some threads, they actually are the same as another one. But try to avoid it by tracking related threads. If you really want to use multiple resources, CAPEC, and perhaps extend it with some other thread catalogs, try to identify the related threads upfront. Not going to go over all of them, but another one that I think is very important is missing threads. So in CAPEC is based on attacks. But there are threads which are not necessarily always linked to an attack. For me, an attack is kind of a subset of threads, but there are also non-attack threads, like and OSA calls them more technology threads and the force majeure threads. That's also what you saw in my Excel list, where there was no link to a CAPEC thread. Well, those are mentioned here, and you should be aware of them, and you should not ignore them. But in practice, I think it's usually a limited set of threads that you can also build upfront and add to your thread catalog independently of the CAPEC threads. The last one that I want to mention is the paralysis by analysis kind of, I'm not sure if I can call it a theorem, but we or you as security experts, we typically have a good understanding of technology, and we want to analyze things more and more in depth. But we should attempt to, especially in architectural threat modeling, we should attempt to avoid that by communicating also with the business-minded people who will actually be able to tell you what they see as a problem. And then we touch on the business attributes, which is perhaps for another talk as well. But that's something to watch out for. Sometimes you have to say, okay, we have these threats. They may not be 100% exhaustive. They may not always be 100% correct even, but we have the threats. Let's now start defining the controls so that we end up with some principles that we can use in practice. So thanks. So here you see my bio. I'm not going to go over it, but I'm curious to see, Alan, if we have some questions in the meantime.
Yes, so there were two questions that came in. The topic was layered threat modeling, and the question is solution threat modeling versus architectural, I suppose, enterprise threat modeling. Yeah, you presented the two at the beginning. So the net is, can these be done, or should they be done independently or in conjunction?
Well, that's indeed a good question, and I think it depends a bit, but I don't think they always should be done in conjunction. I think you can see them indeed as different layers. And typically in enterprise architecture, you start with reference architectures with patterns, etc. And those ones you can model, you can threat model. And the solutions, there can be many solutions making use of similar reference architectures. And for all of these solutions, you should be doing solution threat modeling, but they can refer back to a similar architectural threat model session in which the reference architecture was assessed.
Okay, thank you. Then the second question has to do is the following: is the approach presented tooling dependent, or is it compatible with other tooling like Spark's systems?
Yeah, well, so here I showed you indeed Archie, and because it's open source, it's easy to use. I'm not saying that tool is fully enterprise ready. So indeed Sparks and Mega or whatever other toolings, they may be a bit more enterprise ready because they have a shared repository. But I don't think it matters that much. So, okay, we have some scripts that we use to export this table automatically. It's not that you cannot do this in other toolings. So it's not tooling dependent. No, you can use this approach in any kind of tool that you use for enterprise architecture.
Okay, thank you. The audience, are there any? We still have a bit some time here. We have 10 minutes before the end of the session. Are there any other questions or comments? I think you have to use the Hoover platform, but
I can also take a look at the Hoover platform, but indeed they should be coming in. I see actually some questions in the Hoover platform, Alan. I'm not sure if you see them.
Probably I didn't.
So let me go over them, because indeed I see some questions and we still have a couple of minutes.
Yes.
So I see the first question here: how often do enterprise threat models get updated? What are the triggers? How do changes get propagated towards the solution level? Very good question, and that's I'm not sure that I will be able to answer that immediately. As usual, it depends. But what we found as something that may work is actually to at least review them annually. Perhaps that's normal. And the triggers are typically if you start seeing that things start to go wrong. So and that's where you need a feedback loop. If you start seeing that during your penetration testing, during your red teaming, we start missing more and more threats, or there are more and more successful attacks, perhaps from your bug bounty platform, they should actually feed back to the enterprise architecture level, where we say, okay, this capability, it seems to be missing, because we keep on having problems there. So let's start focusing. Perhaps we need a new reference architecture on whatever component that we use. So kind of a high-level answer. I realize that, but this is also a very difficult question to answer. But I guess if you have the correct feedback loop, that's very important, and that can be one input to know when you should be updating some of the threat models that you already have in your organization. Let's see. How do you create modeling out of existing big applications? Not sure if I understand the question entirely. I'm also not going to interpret it. So for the person who asked it, if you can elaborate it a bit, I will come back to it. Can you recommend certification material for architectural threat modeling? Well, of course, Archimate, I think is key, and I don't want to. Well, I actually like Archimate, but there may be other notations. But you can get certified in Archimate. I think that's an important prerequisite, that you need to know the notation that you are using. But for the rest, there are not many threat modeling certifications that I know of. There are many good books, so I think you should always start also from the solution threat modeling. And the book of Adam Shostak, for example, is a no-brainer to read. You should be reading it. But I don't know any certification material, official certification for really architectural threat modeling. Maybe an ID to start with it to the person who asked it. Does the tool and methodology you described work for non-architecture as well? Yes, of course. So this was just an example that I created for this talk. Again, I'm going to keep using it. But this was just an example that I created. But you can apply it also to non-cloud architectures, for sure. You also have non-cloud reference architectures, perhaps on your API stuff with gateways and controls that you want at microservice level or perhaps at gateway level. That's for me also an enterprise architectural discussion, a reference architecture that you need regardless whether it's cloud or not. So yes, of course, this should also work for non-cloud architectures. Will architectural threat modeling free myself from solution threat modeling? No, not at all. So this is two independent things with two different goals. It's very important to do both. But as was discussed in the first question, you do not necessarily for each solution have to do architectural threat modeling. You can probably reuse for many solutions the same reference architecture, the same reference pattern. So short answer to the question, no, you still need solution threat modeling. Are there any open and similar alternatives to Archie that are hosted or automatable? Well, a very good question. There are many alternatives to Archie, but most of them are pretty expensive. Sparks is, I think, the most known one that Alan also mentioned in one of the questions. And they are hosted. I'm not sure if you mean cloud hosted or on-premise, but I think you can choose with Sparks, but I'm not a tooling expert in all of the tools. But there are many there are many alternative toolings that you can use to actually model Archimate. Archimate is a notation. Archie is just one of the tools that you can use to build Archimate models. The existing application is complex and not sure from where to start to create modeling. I guess that's related to the question that I did not understand completely. But yeah, for me, that's actually a question about architecture. So if you start from an existing application, it's typically easier to start with the structure. What application do you have? A structure. It's a kind of a definition in Archimate. But if you allow me, I will skip this question in the interest of time. I see that there is one more. We have 1 minute left. Yes. Engineers, developers tend not to use Archie or UML these days, preferring light modeling. Again, the cloud providers don't use it in their architecture material, as far as I know. Does a heavy tool like Archimate alienate engineers, developers, given the learning curve? Oh, this is a very nice question. I think we need something, and again, that's why we have these layers. I don't say that developers need to create these models. I still think even in the agile world, we have several roles to play, and we have enterprise or people working at the enterprise architecture level who can use Archie and Archimate. But indeed, they should be translated to some detailed design models that developers use/generate. So I have never said, and I don't want to say, although it may be nice in the shift left approach, that developers should be actually modeling or creating these models. And I'm sorry, but this is an interesting question, but I guess we've run out of time, Alan.
Yeah. We are running out of time. Would you like just to use the last 30 seconds to maybe summarize with one or two key message?
Well, I guess the key message is here. So keep on doing the solution threat modeling, and that's what's related to the question, but also start thinking about architectural threat modeling, and hopefully you can use some of the material that was presented here. I can definitely share some of it as well. I will see how I do it, but then you will see it also in the Wova application.
Okay, thank you, Michael. We have to close now. There are 5 concurrent sessions that are happening in parallel. The next session that will be starting on this room here will be Trusted Types, a world without XSS. Thank you, Michael, and all the best. And see you soon, maybe in Belgium.
Thank you, indeed. Have a nice day, Alan. Bye-bye.
Bye-bye.